Welcome friends. Today's topic is tape recorders, and this is another example of analog recording systems that we are going to learn today. So the main points we are going to discuss are magnetic tape recorders, their advantages, what are the components used in magnetic tape recorders, principle of operation of magnetic tape recorders, and there are three different methods of recordings, that is the direct recording method, frequency modulated recording method, and the third one is pulse duration modulated recording method. So these three methods we shall learn during this lecture. So let us start with what kind of magnetic tape recorders are available in the market. This is an example, simple example of a magnetic data tape recorder. The figure 1 on the left shows the voice recorder of MiG-21, which is placed in the cockpit, and this is a magnetic tape recorder which records the voice data. So below we can say that this one is the basic mechanism we are using in magnetic tape recording. The first one is the erasing head. So here the existing data on the tape, which is moving from left to right in this direction, so this data is erased here. Then this is the recording head where the information is recorded in the form of orientation of magnetic particles, and third one is the replay head, or this is sometimes called reproduction head or playback unit. So we shall go further to understand how basically the magnetic tape recorder works and what are its various components. So let us see the components. First we discuss the advantage, then we will go through the components. So there are different advantages of magnetic tape recorders over the previous kinds of recorders we have studied so far, including the XY recorder. So the first very important benefit is that in the earlier cases we have seen that we can record up to 40 to 60 Hz, but here we can record from the DC signal to few megahertz signal. So first advantage is it can record from DC to few megahertz signal frequency. Then the second advantage is that the magnitude level of the signal that can be recorded through this is very high, that is of up to 50 decibels level. So it can read as high as 50 decibel magnitude or gain level can be recorded. So 50 decibel signal magnitude can be recorded. So there are several such advantages. The third advantage is that the distortion is low. So low distortion, this is very important advantage to ensure the signal quality that we are recording and reproducing. The fourth very important advantage is that signal is recorded immediately, because most of the cases we require to process or rip the signal during the process, but here the signal is recorded immediately and no processing time is involved. So this is one very big advantage. So The next advantage is when the signal has already been processed, the tape can be erased and reused, and that also immediately for a new data. So the system is reusable. Reusability by erasing and re-recording. So this is a big advantage of the tape recording system. One big advantage is this tape recording system has multi-channel recording facility. So you have multi-channel recording facility means at a time parallelly many different input quantities or measurements can be recorded on the same track. So it has multi-channel recording facility. So those of you who have seen or used the audio systems or video systems, there we have the tape drive and tape cassettes, where in audio system we have mono system and stereo voice system, or multiple voices can be recorded. Even in tape drive for audio systems there are provisions of recording 16 tracks, different 16 tracks just in a Dolby digital system you can record in the tape drive. Similarly in the video cassettes we can record the video signals in different channels as well as audio signals in stereo form, like that. So we can make use of the multiple channels. And another one very important advantage of tape recording system is that the magnetic tape recorders provides a convenient method of changing the time base, because when you are recording a certain data and you want to replay it at different speed, many times you have seen in movies that the movie films are shown to be going past very fast. So that is done by changing the time base. So the time base can be changed for replay as fast or slow, or faster or slower than the original speed of measurement in time. So these are the 7 very important advantages of magnetic tape recording system. Now coming to the basic components. What are the basic components? Let us see. First, the most important part of the magnetic tape recorders is, you can see in figure 1, there is a head. This is both recording head and replay head, and also the erase head. So in a basic or standard tape recorder system, in a standard magnetic tape recording system, you have 3 heads, one for erasing, another for recording, and the third one for playback along the movement of the tape. So here I am taking the example of the situation when the head is placed on the film. So this film is actually polythene film on which the magnetic coating is made. These particles in figure 2, you see the moving magnetic tape. These small particles are basically Fe2O3, the ferric oxide particles, which are magnetic in nature, and by magnetism or by application of external magnetism their orientation is changed and the data is recorded which resembles the signal we are trying to transmit or record. So here you have the three heads. These three heads are there. Then you have this portion is a gap between the magnetic flux path. So if the magnetic flux path is moving, there is a gap. So as we know that if there is a gap in the path of a magnetic core, then this offers very high reluctance. So this reluctance is shunted by the tape over here. This tape is actually shunting the reluctance when it is moving or passing by this head. So whatever change is there in the flux associated in the core, here in the core the flux is associated, so whatever change is there, this same change takes place in the film, and the trailing edge, at the trailing edge the magnetism is recorded. So here the recording is done at the trailing edge. So that is how we are recording the information through a magnetic medium on a magnetic medium. So tape head is one component, then there is a recording head. Similarly, there is reproducing head or playback head. So playback head is basically taking back this information, collecting this information because of the movement of the film. This head is getting the rate of change of flux, and that flux is reflected through this coil, and at the end there are amplifiers which are further modifying the signal. And in different cases we are using different processes. So there can be demodulation of the signal, amplification of the signal, and further filtering of the signal before it is reproduced to reuse. So the other one is the tape transport mechanism. As we have seen earlier, the tape transport mechanism, if we go back and see, so the tape transport mechanism here, it will have in the direction of movement, here you will have a pinch roller. So here you will have a pinch roller, so that will control the speed of the movement of the tape speed. Because if we don't have the pinch roller here, because of the change of radius of this, which is the driving motor, the speed will change at this end in front of the head. So that is not advisable. You should have the tape moving at a constant speed, so you are using a pinch roller. So coming to the principle of operation, as we can see that this is the tape. This is when the film moves in this way, the magnetic film is moving in this way. This is getting unwrapped and this is getting wrapped like this. And here you have the supporting free roller, and this is the pinch roller, and the first one is erase head, second one is recording head, and third one is playback head. So you can see how it is working. When I have to record a signal, so input is reaching here, it is modified through different techniques. We will see a little later how different recording techniques are used. So record amplifier is there, and from there the information is entering the head. So once the information is entering the head, it is entering in such a way that the coil inside is having the rate of change of flux. So the input signal will be having a combination of input frequencies, but I am assuming one frequency omega for your convenience, and I say that a flux is produced which is equal to Ka sine omega t. So the signal is recorded due to this flux, and there is information about the frequency, and when it is reproduced, so reproducing EMF will be proportional to the derivative of the flux. So the rate of change of flux is recorded along with the number of turns of the reproducing head. So this is d phi by dt. This is equal to k1 Na. Now this omega will come out cos omega t. So it will have the reproducing head will have the information about all this. So the number of turns will modify the reproducing voltage, and the information of the frequency associated is reproduced. So because of this feature, when the tape is moving in front of the head during the recording period, not only the change in amplitudes of the signal is recorded, but also the input frequency is recorded, and along with that, at a given speed of the tape drive, because of the constant speed of the pinch roller, the record of the data at each instant will actually replicate the happening of the physical process which we are going to record, or which we are going to use and reproduce. So that is how the signal is recorded on a tape drive and reproduced. So going further, let us see the first method of recording, because we are going to discuss three methods of recording, and then the simplest method is the first one, is the direct recording, where the input signal is getting recorded as well as reproduced. So when I am first trying to record the signal, so this is the input signal, you take this as the input signal, this is the input signal, and this is what is happening after recording. So you can understand that there is a manipulation of the signal quality once it is recorded, and similarly the quality of the signal will again changed when it is reproduced. So especially there are more deteriorations near the end of the signal. So because of that, we need to go for further processing of the signal so that the signal can be reproduced honestly. In electronics, you will learn and understand that for using silicon devices, we require a minimum bias voltage of 0.7 volt DC. So if the input signal is less than 0.7 volt DC at the base, so you will have trimming of the signal. Similarly here, you will see that we need the basic biasing. So these two figures, figure 1 and figure 2, are basically the signal without bias. So we can see that there is deterioration of the signal. So let us see how the biasing will impact the signal. So we have three figures. We go to the figure 1 for DC biasing. In case of DC biasing, you see that the signal deterioration at the end is minimized, but the reproduced signal is not 100% deterioration free. It is less deteriorated or distorted, but a lot of noise is added in this case if you are using the DC bias. So for that, we have an advanced DC biasing technique which is shown in figure 2. So here again we can see that the DC biasing is reduced, but again it is not 100% perfect signal. So because of these DC biasing methods and its drawbacks, we have gone for the third technique, which is the AC biasing technique. So in basic electronics, you will learn all these three techniques, how the biasing impacts the signal in detail. Here, for the sake of your understanding, I have recapitulated the topics along with the figures. You can see the input signal is modulated by a high frequency signal. Here the input signal is here. You should get that the input signal is here like this. The input signal is here, but this is modulated by a high frequency signal. Here you have a high frequency signal. So this high frequency signal is modulating the input signal. So you are having basically the signals reproduced here. The two signals are reproduced because of the AC biasing, and the average of this signal is a final signal here at the center. where I am having the final value of the signal which is reused as and reproduced, which is free from any noise and minimum distortion. So in this case we see that the direct recording method, here the function cannot be used without biasing by an AC modulating signal. What I mean to say that if in direct method you are trying to bias it with a DC signal or more advanced DC, then the reproduced signal will not be the honest replica of the actual signal. So we require to bias the input signal with a signal of higher frequency. So because if we are using a DC signal and the magnitude of the input is reduced, then a limit is reached when the reproduced head voltage is equal to the voltage due to the inherent noise in the system. So the noise will dominate in that case. That is why we cannot use the DC bias. We require to use the AC bias in direct recording of the data. So the most important advantage of direct recording is that we can record from the range of 50 Hz to 2 MHz. So the disadvantages of direct recording are overcome again in the frequency modulated signal, because direct recording is used only when maximum bandwidth is required and when variation in amplitude are acceptable. So another superior method is the frequency modulated recording. Let us see how the frequency modulated recording is carried out. Here in figure 1 we can see that an input signal is there which is frequency modulated, and that goes to the recording head, and once recorded signal has to be reproduced through playback head, it is demodulated and we are removing the carrier frequency through a low pass filter, and reproduced signal is generated at the output. So we can see very clearly from the figure that first one in the figure is the actual signal to be recorded. This is the actual signal to recorded. This is the carrier frequency, and this is the modulated signal. So what happens in the modulated signal? Based on the input signal, here you can see the effect of this here. So based on the input signal, upon modulation we will see that the signal is changed. The modulated signal is changed, and throughout the range of the modulated signal, the difference due to the input signal will be observed. So this is actually the deviation from the central frequency. If we take the central frequency as Fc, so the frequency of the modulated signal will deviate around the central frequency. So if I am taking the central frequency, say I'm taking central frequency Fc, so the modulated signal will have frequency Fc plus minus F signal. So this is the carrier frequency, this is the signal frequency. The final modulated signal will have this frequency. So we have two parameters to study in frequency modulation method. First one is percentage deviation. First one is percentage deviation. So I write here percentage deviation over here. So as I have taken the carrier frequency, central frequency as Fc, so and deviation, suppose the deviation at an instant, frequency instant is delta Fc, so I can find a percentage deviation as delta F divided by Fc into 100. So you can use this information for determination of the deviation from the central frequency. So another parameter which we'll discuss in frequency modulation technique is the deviation ratio. Second method is the deviation ratio. what is the deviation ratio? So this is represented by delta, and whatever is the deviation in the frequency, that divided by frequency of the input signal is basically the deviation factor. So this is deviation factor, this is deviation factor, this is deviation factor. So a system with a very high deviation ratio generally has a low noise figure. However, the change in the frequency is limited by recorder bandwidth and the input data frequency, and must be kept high to accommodate all the data signals, because if the deviation ratio is poor, then you cannot modulate the complete signal to be reproduced. So let us go to the next method. So the pulse duration modulation recording method, this is one of the most utilized and used method, because in this method you can record the multiple of input data at the same time, as because you are using the signal in frequency sliced mode. So in different slices of frequency you can record the data, and that is why pulse duration modulation recording technique is very popular in the market. So if the input frequency is very less, I mean if a data has to be measured, suppose a process data is coming, suppose a temperature changes has to be recorded along with the change in humidity. So all these data are slow changing data. When the data is changing slowly, so its frequency is less, it means that the carrier frequency need not be very high. It can be a moderate frequency which can modulate the process data or the measurement. So a lot of such information can together be recorded using pulse duration modulation. So what happens exactly, you see in the figure, we see that this is the input signal, this is the input signal, and at each sampling instant I am generating a pulse based on the amplitude of the signal. So if the amplitude is high, then the pulse generated will be high, and if the amplitude is less, then the pulse generated will have less width. So amplitude of the signal is transformed into the width of the signal. Amplitude of input signal is translated to pulse width. So here the pulse width is again demodulated at the receiving end, and in that way we can reproduce the original signal. The condition for this is that the slow changing process data can be recorded in multiple numbers. So these are the three basic data recording techniques which are useful in industry, and we refer to these techniques for different applications. So this much is for today, and we will see the digital techniques in the coming lecture. So the textbook used is by Professor A.K. Sawhney on electrical and electronics measurements and instrumentation, and most of the topics we can collect from this textbook. So if you find this lecture useful, you press the like button and subscribe the channel. Of course, you set the bell icon so that you can get the notifications. So friends, thank you for your patient listening. Thank you.